For our senior design project, we have created a computerized maintenance management system, JNDR CMMS. CMMS is a software package that maintains a computer database of information about an organization's maintenance operations. Current CMMS are generally based on an asset-based methodology. In our system, we will be extending the asset-based methodology, allowing us to treat assets as a collection of parts that have a business need and can be maintained separately or collectively. Our project involves creating a web platform deployed on the cloud that will allow us to generate work order, manage asset or part, user management, schedule preventative maintenance, and monitor assets using condition-based maintenance. Our software aims to cater to the needs of industries such as manufacturing, who need more complex systems for their maintenance needs, like Unilever Lipton Tea Factory. Within our work order module, a work order is a task raised to fix an issue with the machine. An operator can then raise an open corrective work order for an asset when an unscheduled breakdown occurs. A technician can then start the open work order and can add parts, marking them as replaced if needed. Once work order is completed, the technician can then complete the breakdown analysis. Work orders are created on an asset which is added through our physical module. Within our physical module, before registering the physical assets and parts in our system, an inventory manager can create logical parts and assets. The logical parts created can then be registered as physical parts within the logical assets. Locations are sites in the factory that have physical assets in them. In locations, we can register physical assets from their logical type. In cases where physical assets differ from their logical type, modifications can be made by adding new parts, detaching existing parts, or reattaching removed parts. Managing users within our system and their capabilities is done through user management. Within our user management section, an administrator can add new users, create user groups with group permissions, and manage users through these groups. Another powerful capability of our system is to schedule work orders in advance using the preventative maintenance module. Within our preventative maintenance module, a PM planner can create a work order template known as preventative maintenance record for assets that can be scheduled periodically and pre-assigned to a technician. Parts can be pre-added to the preventative maintenance record. To accurately schedule work orders, we rely on the operational calendar module, which allows us to enter the predicted running days of a location and in turn of all asset locations in that location, or update past records. An asset calendar is also provided in cases where the two differ. For ease of use, weekly defaults can be set up in advance that can be applied to all calendars. Preventative maintenance records can be used to create scheduled work orders whose dates are calculated based on the period and the operational calendar. If needed, changes can be made to the scheduled work order. Finally, we have the condition-based maintenance. This module allows maintenance to be performed when certain indicators measured through sensors show signs of decreasing performance or upcoming failure, allowing for work orders to be created automatically. Users can create a condition-based maintenance record for an asset. The user can see the sensor values that have been recorded by our system in a graphical view. Our system is built using a microservices architecture developed using the Spring ecosystem and is to be hosted on Azure. The requirements of our project were given by Unilever Lipton Tea Factory, taking their issues into consideration with their current CMMS platform, who will be using our system to maintain their equipment. Our system allows for more fine-tuned maintenance since we prioritize both the health of an asset as well as its parts. Having scheduled maintenance at the part level also increases the lifetime of that part, which is the added benefit of decreasing costs as parts are replaced less often and profitability is increased as downtimes are reduced due to unexpected breakdowns, leading to overall equipment efficiency. This project was developed by Dsilva, Najia Mustafa, and Dhriti Adyanthaya. The academic advisor is Dr. Raafat Abu-Rukba and our industrial advisor is Abdalla Gesrou from Unilever.